system like Blur and Meteor do not have. In fact, we are modifying Blur and Meteor to suit the complexities which are there within the Indian language system. Now here, for example, we have shown you a Blur matrix which works, but we are not very happy with it. The tools exist, but we still prefer to go for manual testing. Because we have found the manual test bed is the final word. Machine automation still does not give the right outputs.
Could you use reference translations of all the combinations?
Yeah, all the data is fed inside, and from this you are getting the output. So the system is trained, and we are doing similarly for Meteor. For example, Meteor requires more complexity because you have to give synsets as they call the whole word net. So we have provided word nets also. But we are not being very happy with the results. Now I don't have much time, so I'll run through this. I'm concentrating more on the linguistic testing. See, I'll just talk about the basic linguistic testing which we have submitted the system to. I still feel linguistic testing is very, very important for any machine translation. We have been testing Google also informally along with the existing machine translation systems which are under testing to see what a third-party translation system also gives off. I'll give you the results much at the end, Google Trans as it's called. Now, these are the areas we tested. Some are extremely complex for which a machine translation, even very sophisticated like Systran or ProMT, fails miserably. It just cannot handle. So, these are the areas, although to my best of my knowledge, I think ProMT is one of the best systems. I've used it extensively and I find it passes practically all the tests apart from the last few ones which are there, things like pragmatics and to a certain extent rhetorics. Their ProMT is a miserable failure, but otherwise it's excellent. Now these are the areas which we are concentrating on. Some areas I'll point out while we are talking about ProMT also and Systran, why they fail, because we've been testing along the range. See what happens when data is coming in from the web, especially I'm talking about web data, things do happen. You have things like spelling correction which is there. You can see in English I give an example of strength and deeply. Unless you have a spell checker through which systems like Systran or ProMT do allow you to spell check accurately. You can do a spell check initially and then your translation will be happier if you do that instead of just doing it strictly and pressing the button and say translate, you're going to get junk. So one of the major things that comes in orthography is things like misspellings. Your etymological variants in Hindi, this is a major problem. The word Hindi itself, as Mr. Kulkarni explained, can be written in two ways. One is with a dot and one is with a H-I-N-D-I, let's say H-I nasalized D-I, and both are correct. Now the engine, the translation engine has to have all this information inside. Now you can see here Gardan and Gardan. One Gardan is coming from Urdu, which is written G-A-R-D-A-N, and the other is G-A-R, short form of Gardan. So one is Garadan and the other is Gardan. Both are equally accurate and accepted within the dictionary. This creates tremendous amount of problems. This creates what are known as etymological doublets coming into the system. Your nasal variants, which I gave you an example of. You have, for example, English loans, which are popping in. Indian languages, like all languages, have started accepting. And the funny part is, when you have the phonetics, we have introduced two characters like this, which you can see, which have been added. Unicode has accepted them. This is the sound of A and O, which Indian languages didn't have. So, for example, the famous game of cricket has both bat and ball. So, you have bat, A, and ball. Hindi tends to also make it bat become bet, marry becomes mairi, etc. So, what you can write a word marry, for example, as marry with an A. You can write marry with an I, mairi, and both will be accepted by the Hindi speaker. Same thing happens in a lot of other languages, Gujarati also, Ulto Kano as we call it, or Kiti, I'm just giving you an example. And finally you have acronyms which were handled yesterday also. Systems do handle acronyms. Like I'm giving an example of local thing, a local party, Bharatiya Janata Party, Bhajapa as it's called, and it ends with that. So when it comes to this, one problem of Indian languages is we don't have upper and lower case. So name entity recognition becomes a huge problem in that sense. Whereas in English, to a certain extent, capitalization allows you to do name entity, any R as proper norm or whatever it is. Now here you have something which is ill-formed data, which is coming from the web. This is live data from the web, and you can see what is happening. You can see the first example, mixed characters. We write, unluckily in Hindi, we tend to mix both English as well as Hindi. You've got a good example, April ka mahina, month of April. Half is written in Hindi, half is written, as you can see, in English. This is from the blogs. Okay, your control characters popping in. We were just discussing in the morning about zero is joiner, non-joiner. This is a horrendous problem. And sometimes people put in all types of weird characters inside the data, which results in the translation engine failing totally on it. You have hidden characters, as I said, zero is joiner, non-joiner. You can see here an ill-formed syllable. You can see that ek, you can see that round thing, which we call the round form. It shows that this is a, you can see here, this one, it shows that this is an ill-formed character. The round, in linear languages, we have invented this structure, which Unicode has taken, we call it the Golu, the round form. When you see this, it means the syllable is not properly formed within the word. And then you can see here, for example, this is an interesting problem because it leads to spoofing also. You can see the last two. Do they look any way different? But they have been written in two different ways. One is with the zero joiner, non-joiner, as you can see inside here. Oh, sorry. You can see here zero with non-joiner is popped in here, and here you have no zero with joiner. You can spoof with this. See, you in Indian languages, or you can do it even in English for that matter, it doesn't bother you. Control Shift 1, Control Shift 2 especially allow you to insert what are known as zero with joiner and non-joiner. They are more display variant creators. And when you put them together, you can either join the character or you can split it open. That's why the two names are called joiner and non-joiner. Now you can see here, when this enters into a dictionary, how is the dictionary going to know that for the storage, this is going to put SUN and then you have a zero with joiner. The engine says, machine translation engine says, sorry, I can't locate the word. It fails on translation. So this is a serious problem in Indian languages. We are trying to come to an agreement with the major developers like Microsoft, IBM, Linux to stop this process of putting in zero with joiner, non-joiner. They are basically evil characters, as I call them, because for NLP work they are disastrous. Now you have got a third problem which I raked up a bit earlier. Name entities. As I said, you cannot have capitals in Indian languages, so it's a big problem. So names, especially in Indian languages, can be translated as Charminar, the famous Charminar of Hyderabad, or can be translated such as Red Fort, which is translated literally into English as Lal Killa. You can have the Taj, and unluckily you have the Taj which is in Bombay, which is also the Taj Mahal, which was the target of terrorism, and you have the Taj Mahal which is in Agra. Disambiguating becomes a huge problem in name entity. Numbers, these are another problem. Now this, some of you are familiar with Urdu, know that Urdu does something very funny. Everything is written from right to left in Urdu, but numbers are written from left to right. So you have to learn to disambiguate that feature also. Now in case of languages like Marathi, Tamil, ordinal numbers, measure, time, dates, etc. are all extremely complexly written. You can see 5th to the 6th. In English it would be easy, but English also has that problem. 5th. Now here in Marathi you can see Pachvi se Chhatti, 19 Shatabdi mein 5, and now here you have a kilometer. You can see this form. So when these type of abbreviations etc. occur, the engines have to be tested whether they can handle this type of stuff or they fail on it. A lot of engines fail. So I'm continuing with this. You can see the complexity. In morphological testing of postpositional temporals for dates have to be handled. For example, in Tamil or Telugu or Marathi, everything is joined together. So what happens is dates and the characters are all written together, and the engine has to learn to disambiguate and split it out. Issues such as comma placement in case of digits